All right, welcome back to the second episode of these matrices that we have been considering. Now, in the first episode, we looked at definition of a matrix, the notation of a matrix. We have looked at types of matrices. Then we looked at equalities of a matrix, the condition that will make a matrix to be equal, and how to use it, how to apply it in solving problems. Then we proceeded in calculating the addition and subtraction of matrices. And we ended that section with the multiplication of a matrix by a scalar quantity. In this episode, which is a continuation of where we stopped, we are going to look at the multiplication of a matrix by another matrix. And I will share my screen in order for us to take our bearing from there. Okay? All right, so this is what we have, multiplication of matrices. Now, two or more matrices can be multiplied together if the column of the first is equal to the row of the second matrix. The column of the first matrix is equal to the row of the second matrix. Now, but it may be difficult for some students to decipher or decode this. Some students, after some time, might forget. They may not say, is it the column of the second equals to the row of the first, or is it the row of the first equals to the column of the second, or is it the row of the first equals to the row of the second, and all that. That might bring confusion and definitely lead to failure. So to navigate that problem, it is advisable that students should write the order of the matrix rather than the matrix themselves to check for the compatibility of the two matrices, whether they are compatible under multiplication, whether it is possible, whether it is feasible. Example, here, this is matrix A times matrix B, okay? A is a 2 by 2 matrix, so I'll just write 2 by 2 matrix order, then multiply by matrix of B, and B is what? B is row 1, row 2, so it is a 2 by 3 matrix order. Now, when you look at examine the adjacent numbers of this multiplication of orders, over the adjacent numbers are equal because this is 2 close to this 2. That was by adjacent number. So because the adjacent numbers are equal, then of course it is compatible. That means it is possible to carry out this multiplication. Assuming you have a matrix multiplication of this nature, let's say you have a matrix that is 2, 4, 5, 6, and multiplied by another matrix which is 1, 3, 4, 6, 5, 0. Now you have something like this, okay? Let's say you have something like this. What are you going to do? Of course, this is what? For this one, it is what? A 2 by 2, okay? Now, multiplied by this other one is also, this is also a 2 by 3, so it's also possible. Now, let's say you now increase this one to, let's say 0, minus 5, and 2, okay? It now becomes a 3 by 3 matrix, and because the adjacent numbers are not the same, then it's not possible to carry out the multiplication. So you now write that this multiplication, this matrix multiplied by this matrix is not compatible, or it's not possible, or it's not feasible. All right, so that is the easiest way to navigate that, rather than this long grammar that is being stated here. Of course, that is what you find in textbook. But of course, this is just the simplest way. As you can see, I have presented it in a Word document there. All right, so that is how we know whether two matrices are compatible under multiplication. Now, after you have been able to determine whether they are compatible under multiplication, the next thing you need to do is to now go ahead and multiplying those matrices together. Okay, here they are compatible, here for this one they are not compatible. So you now go ahead and multiply the matrices together. How do you multiply? In multiplying a matrix, you use the row of the first matrix against the column of the second matrix, or each of the column of the second matrix. So that becomes your actual multiplication, okay? You use the row of the first and multiply the column of the second. That's what I have typified here, okay? This red arrow represents the rows of the first, and this red arrow pointing down also represents the column of each of the second matrix. So this row multiply this first column, this also goes for this second one, the row also goes for this third column, and you have the answer there, all line up in a row. Then this another row, now come and apply this second row, this first column, second column, third column, you also have your answer lined up here. All right. So there's one good thing I also forget to tell you, that when you test the other multiplication, for instance, you have a times q, and of course, let's say me use this one, 3, 4, 5, and 6, okay, multiplied by 3, 4, 5, 1, okay, or 1, 2, 0. All right, so you have something like this. Testing the order 2 by 2 multiplied by 2 by 3. You now see that the adjacent numbers are equal. This 2 is equal to this 2. They are the adjacent number. Now, what is remaining is a 2 by 3. So it implies that with this method, you already know the nature of the answer you expect to have. So we don't get a 2 by 3 matrix, then of course, you know you are wrong. All right. So let's just go to our example, and of course, we are going to understand better. All right, so now we have example here. It says simplify the following. Okay, in this example, all right, simplify the following. Okay, so I have number 1. So what am I going to do? Let me just divide my board into several segments. Okay, so that it will be easy to work upon. So let me just divide the board into several segments. All right. Okay, so we have that. Now we have the board ready. Okay, so we have question number 1, solution. Okay, number 1 is a we have 3. We have 3 and 4 multiplying by 2 and 5. Okay, so let's test for compatibility. This is a row matrix, so it is 1 row and 2 columns. 1 row, 2 columns. Okay, 1 row, 2 columns, 1 by 2. Okay, multiply by, this is 2 rows, 1 column, so 2 by 1. And of course, you can see that the adjacent numbers are equal. So 2 will cancel 2, so they are equal. Then we're going to have a 1 by 1 method. That's just a single number enclosed in a bracket is what I'm going to have. So this is the check. It's not the answer. And of course, it's not compulsory that you carry out this check. You can do that visibly. It's not compulsory you show it. Okay, you can do it in a piece of really rough. And of course, before you start carrying out your calculation. All right, so since it's compatible, we'll now do the actual multiplication, which is now a row multiplied by a column. So take the row, I will apply the column of each. All right, so in doing that, 3 will lap with 2 and 4 will lap with 5. So we're going to have it as 3 times 2 give us 6, okay, plus 5 times 4 will give us 20. Okay, it is the addition of products. Okay, so we're now going to have 26 as our final answer. So that is a single value there closed in a bracket. That's why it is a 1 by 1, 1 row, 1 column. So that is pretty easy. Okay, so for number 2, I'm going to take number 2 here. For number 2, I'm having 9, 2, 3 minus 2, and 7, 3. Okay, now testing for the order to see the compatibility, I want it is 2 by 2 matrix order multiplied by 2 by 1 matrix order. So you now discover that they are compatible based on this test. Okay, because adjacent numbers are equal. So of course, our final answer is going to be a 2 by 1 matrix that we're going to have as our final answer. So let's see that. So we'll now do the actual multiplication now. Remember, it is row multiplied by column, each row of the first multiplied by each row of the second. All right, so in doing the actual multiplication, so 9 will have 7, because when you stand 9 and 3, you're going to have 9, 3, they have 7 and 3. So this one will multiply this one multiply this, they add the two answers together. So it is an addition of sum. All right, so take note of that. So 9 times 7 is going to give us, so I'm going to have 9 times, this one will come in 9 times 7, so you have it as 9 times 7, okay, plus, okay, that's the answer for that one, plus 3 times 3 give us 9. So 9 times 7, I'll just quickly say 63, okay, 63, okay, plus 3 times 3 to give us 9. All right. Then this row now, we multiply this column. Remember, this row is under this row. So your next answer will also come under this first answer you have here. All right. So you come under here. 2 times 7 is 14. So you have 14 minus 2 times minus 2 times 3 minus 6. So you have minus 6 here. All right. So this is what you have, and you finish up. You simplify. 63 plus 9 give us 72, and 14 minus 6 will give us 8. So this is answer equals to uh, the answer there. So you can see that it is a 2 by 1, row 1, row 2, and column 1. So this is a 2 by 1 matrix order as I explained earlier. So that's how we do this second one. So how about question 3? Now question 3 is more demanding because it's a given that P is equals to that, matrix Q is equal to that. Find PQ if it is defined, and also the next one if it is defined. All right, so what do we do? So let's look at what we do here. So dividing my board again into various segments. All right, so now solution. Well, I'm talking about number 3 now. And I guess that we are updating our notes. Okay, remember this is a homeschooling, so I'm expecting you guys to write. I'm expecting my students to write, whether you are watching from home and all that. So just write while you are watching this video, so you can have a comprehensive note. All right, so I'm talking about number 3 now. So is PQ defined 3I? All right, is it defined? Okay, let's see. PQ, okay, PQ give us P is what? A 3. P is a 3 by 2 matrix order multiplied by Q, and Q is a 2 by 3 matrix order, 2 by 3 matrix order. And of course, we see that it is defined because adjacent numbers are equal. So it means, and we're going to be left with a 3 by 3 matrix order. So it is defined. So I cannot say that PQ is defined. So now that is defined, then go ahead and do the actual multiplication. So what is P? Our P is 3, 4, 5, 2, 1, minus 1, multiplied by Q. Q is 4, 5, 3, 1, minus 2, and 4. All right. So remember the process that it is the row. Remember, it is the row of the first. Okay, each of the row of the first multiply each of the column of the second. All right. So take note of that. Be very careful to see that you do that judiciously. Okay. Now 3 and 2, the first row, multiply this column. So what am I going to have? Okay, 3 times 4 will give me 12, plus these 2 will now overlap with 5 to give us 10. So that is the answer I get from this row multiplying this column. Okay, so this is the first row multiplying the first column. Then the first row also will expand the second column, expand the third column. Similar to what we normally have in algebra, when you have x plus y, okay, expanding 3 minus 2 all over 5 plus k. Okay, just pick the first number x, you expand, multiply this, multiply this, multiply this, you sum up everything. Pick the second number, multiply this, multiply this, multiply that, and so you sum up everything. So that is just what we are doing here. So it's, but in this one I'm talking about matrix now, so it's not just like this. So we have used this one to expand this column. So we use this row again to expand this other column. Notice that there is a space here before the next column. So also give a space also to write the next answer we have. So 3 will overlap with 2 to give us 9. Then plus 2 times 1 to give us 2. Okay. And 3 will overlap with minus 2, give a space to give us minus 6. And 2 times with 4 to give us 8, to plus 8. So that's what we have. So I have used this row now to produce this answer because there are 3 columns 1, 2, 3. So that is the 3 answers 1, 2, 3. Now, taking the next row now to repeat the same thing. Now, this row comes under this row. So the next answer will come here, here, and here. So that is what you are doing now. Okay, so now 4, we go again each of the column. 4 times 4 to give us 16, plus 1 times 5 to give us 5. Okay, the next column again, 4 times 3 to give us 12, plus 1 times 1 to give us 1, and give a space, 4 times minus to give us minus 8, and 1 times 4 to give us plus 4. Then the last rule on each of the column again, 5 times 5 to give us 25. Okay, and sorry, 5 times 4 rather. 5 will have with 4. 5 times 4 to give us 20, and minus 1 times 5 to give us minus 5. Okay, and 5 times 3 to give us 15, give a space. Then minus 1 times 1 to give us minus 1 times 1 give us minus 1, and give a space again. 5 with times minus 2 to give us minus 10, and minus 1 times 4 to give us minus 4. And of course, the answer is going to be a matrix, so they should be enclosed in a bracket. Okay, the answer should be enclosed in a bracket because it's still a matrix, so you enclose it in a big parenthesis or a big square bracket. All right, so you now simplify to have your final answer. So of course, our final answer becomes, this will give us 22. All right, 11 for this one, and 2 for this side, and here it should give us 21. Okay, here it will give us 13, and here will give us minus 4, and here will give us 15, here will give us 14, and here will give us minus 14. Okay, so this is what we obtain by carrying out the multiplication. All right, I guess this is very simple for every one of us to follow. So I'm going to wipe the board now so that I can look at the next question, 3II. So I'm wiping the board now. This is not a live class, so I'm not waiting for students to write. So for those of you watching over the YouTube, you can just pause the video and update your notes. Then, of course, you release the pause again and continue listening. All right, so wiping the board now. I want to look at the next question. Okay, the next question, I want to demarcate the board again. All right, so demarcating the board again. So I'm looking at the next question, 3II solution. 3II. Okay, I don't know about QP. Now QP, what is the order? Let's test whether it is compatible first. Q is a 2 by 3, 2 rows and 3 columns, multiplied by P is a 3 row and 2 column order. All right, seeing that the adjacent numbers are the same, they are equal, and when they cancel themselves, we'll have a 2 by 2 remaining. So our answer is going to be a 2 by 2 matrix order. All right, so doing the actual multiplication now. So what is our Q? Our Q is 4, 5, 3, 1, minus 2, and 4, multiplied by the next one. P is 3, 4, 5, 2, 1, minus 1. Okay, don't forget that it is each row against each column. So each row multiply each column. Okay, don't forget that. All right. So take all this row and multiply all this column. That you collect the answer and you give a space. Of course, take this row again and multiply all this column. You should give you an answer also. So let's start. So 4 will go into 3, 3 go into 4, minus 2 go into 5, and so on and so forth. So we have that. So 4 times 3 is, okay, let me change the color of this. Okay, 4 times 3 is 12. So I'm going to have 12 plus 3 times 4 is 12. Okay, then minus 2 times 5 give us minus 10. So that's the answer for this row and this column. There is a space after this column to have this column, so I give a space again. 4 times 2 is 8, plus 3 times 1 will give us 3, minus 2 times minus 1 to give us plus 2. Okay, so that is it. So I have finished using this row on each of the columns. I will now come with this row now that comes under this row. So my next answer will come under here and under here. All right, so I will now use this row on each of these columns. So 5 will go with 3, 1 will go with 4, 4 will go with 5. So 5 times 3 will give us 15, and 1 times 4 will give us plus 4, and 4 times 5 will give us 20. So that is the answer for this row and this column. I give a space because of the space before this other column and collect the next answer. 5 times 2 is 10, 1 times 1 is 1, and 4 times minus 1 is minus 4. All right, so your answers collected in a big parenthesis because it is still a matrix you are dealing with, okay? So don't forget that. Okay, so you now simplify finally. This is 24 minus 10, and of course you have 14. So you have 14 here, and this is 11, 13, so you have 13 here, and this is 39. Okay, so we have 39 here, and of course this is 11 minus 4 to give us 7. All right, so do you see that? Do you see what I talked about? It's a 2 by 2 matrix order, as you can see here, 2 rows and 2 columns. So that's very simple. Okay, so having explained that, I believe that this is simple enough for each and every one of you that are watching, and my student inclusive, to be able to carry out this multiplication. So, all right, so I think we need to proceed to classwork so that you can do something for me. All right, so the first part of the classwork is a bit simple, so I'm going to leave that, but if you're interested, of course, pause the video and copy that. All right, so we go into the second part, question 2 and question 3A, to see how many of you are going to get that. So I'm going to give some time for you that are watching over. So please, what I'm going to do for me now is you pause the video, and of course, you attempt question 2 as your classwork. I need to attempt question 2, so pause the video, attempt question 2, this question 2, the whole of question 2, and of course 3A. So don't bother 3B and 3C, because once you're able to navigate through the whole of question 2 and 3A, then it means that, of course, you are a master of this. All right, so I'm going to solve it now because I'm not having a live section of my students. So this is a prepared class, okay? So since I'm not having a live section, I'm just going to go ahead and do the correction. But you pause the video, do yours, and release the pause and see the correction that I'm going to do. So I'm going to do this as a correction, okay? All right, so I'm starting now, believing that you have paused your video. So I'm looking at question 2 now, okay? I'm looking at question 2 to see what is there. All right, so that's question 2. Okay, so I'm asked to calculate where possible those stuffs that are there. Okay. All right, so solution. Let me just divide my board once again, as I normally do. All right, so here we are. Here we are. All right, so solution. We are told that let's see b equals to this and this equals to this. Calculate where possible. We're asking where possible because it might not be possible at all instances. So let's look at 2I to see whether it is possible. C, D. The order of matrix C is a 2-row and 3 column. Okay, I'm seeing this as a correction because I believe you have paused your video. So it is 2-row multiplied by 3 column. That is the order. Then multiplied by D is a 3-row by 2 column matrix. So, and of course, the adjacent numbers are equal, so it is possible to multiply. So we'll now go ahead and do the actual multiplication. C comes first, okay? C comes first. All right, C comes first. So I'll write matrix of C first. Matrix of C is 2, 3, minus 2, 0, 4, and 2. 4 and 2 multiplied by matrix of D, which is 1, minus 1, 4, 3, 0, minus 12. All right, so following the pattern again, each row multiplied by each column, okay? And every answer is contained in the bracket. When a row multiplies a column, you should have an answer includes the bracket. So let's start. So 2 with times 1, All right, so I'm going to have a 2 by 2 matrix. That's what it implies. So now 2 will times 1 to give me 2 plus this row is still multiplying this column, okay, minus 2 times minus 1 to give me 2, all right, and this 4 will times this 4, 4 times 4 to give me 16, okay, so that's what I have, 16 here. So I have finished with this row on this column, and that is the answer in a bracket. So give a space after this column, there's a space here, okay, collect the next answer again, the same row will now multiply the next column. 2 times 3 is 6, okay, minus 2 times 0 will give us 0, and 4 times minus 12 will give us minus 48. All right, so that's the answer for that one there. And we'll now take this row now on each of the column here. 3 times 1 will give us 3, plus 0 times this will give us 0, anything multiplied by 0 will give us 0, and 2 times 4 will give us 8. All right, so that's the answer for that one. Give a space. This row will times this column now. 3 times 3 will give us 9. Okay, 0 times 0 will give us 0, and 2 times minus 12 will give us minus 24. All right, so that's the answer there. And anything close in a bracket, then simplifying, this will give us 20. So we have 20 there. This one, 48, 6 minus 48 will give us minus 42. So we have minus 42 here. And 3 plus this will give us 11. So we have 11. And 9 minus 24, of course, should give us minus 15. All right, so we have minus 15 here. Of course, this is equals to CD. All right. So kudos to you. If you got this right, I'm proud of you. It means that the foundation class is interesting. It's actually doing its work. All right. So let's look at the next question. Let's look at the next question, which is 2II. So 2II. Now we ask DC, and the order of D is a 3 by 2, okay, multiplied by C is a 2, okay, by 3, and of course it's also possible as we are seeing here because the adjacent 2's are equal, so we're going to have a 3 by 3 answer, matrix answer. All right, so going ahead and multiplying D first, so because it is DC, okay, 1 minus 1, 4 3 0 minus 12. All right, multiply by C, and C is 2 3 minus 2 0 4 and 2. All right, so do not forget the process. Each row multiply by each column, so each row multiply each column of the next. Okay, so do not forget that. All right, so continuing with the multiplication, so I'll wipe this part of the board, okay, away now. I'll wipe that part away so that I can continue writing from there. Okay, all right, so I have that. Okay, so wiping that part away, so we can now continue in the next part. All right, so I'll continue my solution now from here. So 1 with times 2, so I'm going to be having, so 1 times 2, 1 times 2 is 2, plus 3 times 3 is 9. Okay, that is that rule, and that this rule and this column, the answer, give a space because after this column there's a space. So I'll give a space, the same rule again we go. 1 times minus 2 is minus 2, and 3 times 0 is 0. So plus 0. Give another space, the same rule again. 1 times 4 is 4, plus 3 times 2 is 6. All right, so that is the answer from the first row and all the columns. So other answers will come here, here, and here, here, and here. Okay, because second row and third row are found under this. So taking the next row now and on each column, so I have minus 1 times 2 give us minus 2, and 0 times 3 give us 0. Okay, anything times 0 give us 0, give a space. Minus 1 times minus 2 give us 2, and 0 times 0 give us 0. All right, minus 1 times 4 will give us minus 4, and 0 times 2 will give us 0. All right, so I pick the last rule and on each column also. So 4 times 2 give us 8. Then minus 12 times 3 give us minus 36. All right. 4 times minus 2. This will now come on this column. Will give us minus 8. Minus 8. And minus 12 times 0 give us 0. All right. And of course, 4 will come now. 4 times 4 to give us 16. Minus 12 times 2 will give us minus 24. All right, so we have this minus 24. And everything should also be in the bracket because it is a matrix, okay? It is a matrix, all right? So everything should come under a bracket. Then you now simplify finally. And of course, let me use a different color to present my final answer. All right, so this will give us 11 minus 2. And this will give us, sorry, here is plus. That is 4 plus 6. Okay. So we should have 10 here. All right. And for here we have minus 2. And for here we have 2. And for here we have minus 4. Okay. Here 8 minus 36 we have minus 28. Okay. And here we have minus 8. And of course, here we have also minus 8. And that is the answer equals to DC. So this is the answer we get for solving D and C together. I believe that that is well explained enough. All right, so the last part of the question, you can pause once again and copy your note and update your note. The last part of the problem now we are looking at is the C. Now let's look at C. Okay, the 2I, 2I. All right. So 2I is what you're looking at now. It's a D square. Okay, which same as D multiplied by D. Okay, D multiplied by D, and D is what? That's the same as a 3 by 2 matrix multiplied by a 3 by 2 matrix. And of course, you cannot see that that's what they say where possible. And I see that the adjacent numbers are not the same, so it's not possible. So I will now say, therefore, that D square is not possible, or is not feasible, or is not compatible. All right, so that's it. And I'm sure that if you have done this by yourself, and of course, this is what you'll be arriving, and if you are getting this same solution, I'm very proud of you, and I want to say thumbs up to you. It means that this video is having an impact on you, and of course, and I will also encourage you to keep subscribing, keep watching, keep viewing more and more, and keep giving me feedback on areas of improvement, on areas that I need to do more videos upon, and of course, I will definitely give a return back with a video on that. All right, so let's look at the next question, which is question 3, before we leave this particular part. Now, question 3 says, given that, all right, so that's the answer for what we have done before. Given that, okay, that P is equals to that, okay, given that P is equals to this and Q is equals to this, R is equals to this, find where possible QR. So remember, I said I'm going to do only 3A, and of course, the other ones is for you to play with. All right. So dividing my board once again, okay, to make it easier, or for clarity's sake. All right. So question 3 is still a correction. Solution 3A. Okay, P is a 3 by 3, so we have QR rather not P. QR is what the asked us to find. QR, and Q is a 3. That's a 3 by 2 matrix, and R is a 2 by 3 matrix. And On exam, cross examination, we discover that the adjacent numbers are the same. So we have a green light, of course, to go ahead. So we just proceed by now doing the actual multiplication. Q is 1, 0, minus 1, 2, 4, and 9, and multiplied by R is 3, 1, minus 8, 0, 2, and 7. And of course, if you have been practicing this, you discover that a time will come that it becomes more easy to do. Okay, as you practice, you begin to approach perfection because you can easily, for me, I can actually navigate some of the processes I'm following here in multiplying this because, of course, I've practiced this over and over. I also had some difficulty the first time I went through it, the same way some of you might be having difficulty, but just take it slowly and, of course, be steady, you will get the answer. So we continue again. So remember, when a row multiplied by a column, the answer is going to be a set of answers enclosed in a bracket. So this row will multiply this column, and that will be a set of answer in a bracket. So 1 will go by 3 to give us 3, and 2 will times 1 will give us 2. So that is the answer for that one. And that same row multiply the next column, given a space. 1 will go by minus 8 to give us minus 8, and 2 times 0 to give us 0. And that row will multiply the next again, give a space. 1 will go by 2 to give us 2, and 2 times 7 to give us 14. So that is the answer we get by this row and on each of the column. Now the next row comes under here. Our next answer will come under here. So 0 times 3 will give us 0. Then, of course, 4 times 1 will give us 4. Then 0 will times minus 8 to give us 0 again. And 4 times 0 to give us 0 also. And 0 will times 2 again to give us 0 plus 4 times 7 to give us 28. So that's what we have. I will now pick the last row on each column. Minus 1 will times 3 to give us minus 3, and 9 times 1 to give us 9, so we have to say plus 9. Minus 1 will times minus 8 to give us 8, minus times minus is plus. 9 times 0 to give us 0, so plus 0. And minus 1 will times 2 again to give us minus 2. And of course, 9 times 7 to give us 63. All right. And of course, don't forget to enclose the answer in a parenthesis or square bracket because it is a matrix at limit. Finally, you now simplify. You have 5. Okay, this will give you minus 8. All right, this will give us 16. And this will give us 4. This will give us 0. This will give us 28. All right, this will give us minus 6, or 6 rather. That will give us 6. And this will give us 8. And this will give us 61. And that is the final answer. I can see 3 by 3 remaining. It is a 3 by 3 matrix order. Okay, so if you have done your own multiplication, of course, just do well to check out the correction that I've just done here, and I'm sure that you will see that you are actually improving. All right, so that is on this. So away from this now, let's just quickly summarize this section by looking at something else, which is the transpose of a matrix. That will lead us to the end of this particular section. So let's look at transpose of a matrix, and of course, I will not conclude this section. Transpose of a matrix. What is a transpose of a matrix? A transpose of a matrix is the changing of rows into columns, or you can as well decide to change your columns into rows, denoted by the letter superscript capital T. Example, this is a matrix A. Its transpose is written as what? A raised to the power T, capital T. Okay, and it's the changing of rows into columns. So for this, for instance, look at A and B here. This matrix of A and B. I will go ahead and, of course, do this for you guys. And I expect you now to do this because I have taught you multiplication. So you can go ahead and do that. You pause your video and finish doing that. I'm going to display the answer for you so you can actually compare the answer you are getting and the answer that I have here. All right, so what is, back to what I was explaining, what is a transpose? I have A. I want to change the rows to column. I pick A now, for instance. Now, the rows are what? Look at the rows. Let's identify the rows. Row 1, row 2, and row 3. So I want to change each of these rows to columns. Row 1, row 2, and row 3. I want to change them to column 1, column 2, and column 3. Okay, so what do we do? Of course, so you just say A transpose, okay, is equals to, now the first row will become vertical, will now become this first column, and first column is going to give me 0, 3, and 2. And the second row will become the second column, 1, 8, and 6. And the third row become the third column as 3, -1, and 1. So that is A transpose. Okay, now I have changed the rows to column. I can also decide to change the columns to row. I'll still have the same answer as I got here. Let's verify that and see whether to give us the same answer if we decide to change the rows to column. Okay, so let me decide to change the columns to row now. I'm changing columns to row. So this is column 1, okay, and this is column 2, and this is column 3. All right, so I want to change each of these columns to row. So C1, C2, and C3. So to change them to row now, column 1 become row 1. So 0, 1, 3 as a column 1 become row 1 as 0, 1, 3. Column 2 become row 2 as 3, 8, -1. And column 3 become row 3 as 2, line it down, 2, 6, and 1. And of course, when you compare these two answers together, you discover that they are the same. So when I decide to change rows to column, I have to change columns to row, the answer will still be the same thing. That's what we call transpose of a matrix. All right. And finally, before I leave this and this section, I'll just quickly do B. Of course, you're not supposed to be repeating the rows and the columns. So just decide to choose to change rows to column or change columns to row, and the case may be whenever they ask you to find transpose. All right. So for B, B transpose, I'll just change the rows to columns. So these are the rows, and of course, row 1, row 2, and row 3 will now become column 1. So give me 4, 3, 1. All right. So this one now give me -3. So I'm changing to column now, -3, 1, and 2. And the last one give me changing to column 1, 0, and 2. So that is B transpose, and that is the answer here. All right. So we are going to stop here. So you guys do this one for me, but let me just give you a hint. For all of you that are viewing, A transpose, B transpose means that the answer I got in A transpose multiplied by this answer I got in B transpose, that is what I expect to do. And of course, I just finished explaining the multiplication of a matrix by another matrix. So use A transpose multiplied by B transpose, check whether it is compatible under multiplication. If it's compatible, go ahead and do your multiplication. Then what is D telling you? D is A, B, or transpose. Remember that it is not the B that's carrying a transpose, neither is it the A that's carrying a transpose, but both A and B is carrying a transpose. That's why A and B has been enclosed in a bracket. Okay, A and B has been enclosed in a bracket with a transpose for both of them. So it means that you have to first of all use this matrix of A, multiply by this matrix of B. The answer you have, which is also going to be a 3 by 3, then you now do the transpose of that answer. That will now become the final answer. And of course, I'm going to display my answer here for you to see. In case you finish doing it, you can of course verify what you have with what I have here. All right, so here is what I have. A, B, and these are the answers. So this is A transpose, B transpose. All right, and of course this is A, B transpose. So I do guess that when you try your own, see whether you are getting the same thing. All right, so we are going to stop at this particular point, okay? And of course, you can see my next subtopic, determinant of square matrices. And I don't expect you to miss the next round of this episode of this series on matrices, because I'm going to deal with determinants, and I believe that you have found this class so interesting and you have enjoyed this class. So please subscribe to our YouTube channel. Also hit the bell button, and also give me feedback on any areas of improvement. And of course, I will definitely make an improvement on that area. If there are areas or topics that you want me to make video upon, just one to SS3, as we use in West Africa, popularly called the grade 7 to grade 12 and all that, or the K-12 system in the British system and all that. Any particular topic in mathematics you want me to make video on, please just feel free to give me feedback, and of course I will make a video for you. But for now, it's nice having you guys on this online self coaching foundational class, and I hope your foundation is getting stronger. For for now, it's a goodbye from me, and I say thank you very much for watching.